Hi there, I'm Eric Lippert. I'm a developer on the C# compiler team, and today I'm going to talk a bit about covariance and contravariance. This is a new feature that we are adding to C# 4. We've made some changes to the framework base class libraries to support this feature as well. And covariance and contravariance is one of those features that has kind of like a highfalutin type theory name, but it's actually a pretty straightforward feature. It's one of those features where things just kind of work the way you think they should. So, I've got Visual Studio 2010 Ultimate Edition here, and I'm just going to create a new project real quick. And in order to demonstrate this feature, I'm going to need a class hierarchy or two. So I'm just going to make a really simple, kind of empty class hierarchy with obvious relationships between the classes. So we'll make an abstract class person. Maybe a person has a name. And we'll make some derived classes from person. So an employee is a kind of person, and a manager is a kind of employee. Maybe we'll make this one concrete instead of abstract. And we could define other classes of, employee, manager and peon or report or something like that. Maybe we'll have a class customer, which is also a kind of person. Okay, so pretty straightforward class hierarchy. We could do this with any kind of class hierarchy. We could say abstract class. We could say that there are games and that a board game is a kind of game. And we could say that chess is a kind of board game, or whatever, right? So we have these little class hierarchies with obvious relationships between them, right? Now, rather than start off by trying to explain what I mean by covariance and contravariance, I'm going to give you an example of what covariance exists already in C# and the way in which it is broken. So let me give you an example of that. Suppose we have a method, we'll just call it M1 for now, and this thing takes a bunch of people. Takes an array of persons. And we'll fill in the body of that later. Right? Now, suppose I have an array of employees. Okay, so I've got an array here. It contains one employee. All right. Oh, actually, I can't say new employee because that's an abstract class. New manager. There we go. Okay. So now I want to call M1 and pass it in employees. All right. Build that. The build succeeded. It built just fine. Now, it seems plausible that this should work, right? You say, I've got a bunch of employees. I have a method that takes a bunch of people. Employees are people, so that's fine, right? The problem comes in when you now say persons 0 equals new customer, right? We've passed in an array of employees. We're treating it as an array of persons, and we're putting a customer into it. And you can't put a customer into an array of employees because customers are not employees, right? But this compiles just fine. And if we run it, then what we get is, unfortunately, array type mismatch exception was unhandled, right? So we've taken what could have been a bug that would be caught at compile time and turned it into a bug that's not caught until runtime. And this is unfortunate, and this is why I call this broken covariance. We want to have these kinds of relationships in the type system, but we don't want to cause more bugs like this, right? So now suppose we have another method. And this one takes an I enumerable of person, right? The thing about IEnumerable is it represents a sequence, and the sequence interface, the IEnumerable and IEnumerator interfaces are read-only. They only provide you methods that let you pull things out of them. There's none of this push things into them business. So you would think that you should be able to go, let's see, I want an IEnumerable of employees. Right, and now this should just work. We should be able to say M2, right? And now we're saying, okay, we have a sequence of employees, and we're passing it to a method that takes a sequence of persons, right? Now, in C#3, this would have given you a compile time error saying there is no conversion between IEnumerable of employee and IEnumerable of person, and that's what we've fixed here. This now builds just fine, right? And well, the method doesn't do anything, but it would run just fine, right? You could have a for each loop in here, and it would just for each over the people and pull out the manager that's in this sequence of employees, and everything would be just fine, right? So the advantage here is that the conversion is completely type safe. We know at compile time that there's not going to be any problem here caused by M2 unless it does something that's known to be dangerous, like it in the author of M2 inserts a cast, right? That you know that a cast might fail at compile time, or at runtime rather. The problem that we want to fix is we want to make sure that things do not fail at runtime because of problems that could have been caught at compile time in the type system. Now, we have some limitations on this feature. The first major limitation is this covariance feature only works on interfaces and delegates, and it does not work on generic classes or structs. And the type argument, right? The type argument is when you say IEnumerable of employee. The of employee is the type argument. The type argument on both sides has to be a reference type. So we don't allow you to say, oh, I have this IEnumerable of int, and I would like to convert it to an IEnumerable of object, because even though there's a conversion from int to object, it's not a reference conversion. Int is not a reference type. And the reason for that is we want to make sure that at runtime we're never actually changing any of the bits in the structure. You say, oh, I've got a sequence of strings and I'm going to treat it as a sequence of objects. Well, you don't actually need to change anything there, right? Every string, every reference to a string already is a reference to an object. But to change an int to an object, you would need to box, and boxing allocates memory and all of that. We want to avoid that, right? We want to make sure that we're just talking to specifically the bits that are there, and we're not changing them. We're just kind of looking at them in a kind of a different way.